Okay, now I just use a circle with the word coil in it for a coil that responds to a current. Current goes through the coil, right-hand rule, magnetic field oriented so that the coil deflects if you have a current, and the more current, the more deflection. Now you experience the fact that the aluminum strip over the magnet deflects when you induce a current, and the more current, the more it deflects. Well, the coil, in class we're talking about the right-hand rule and the way things react and magnetic moments and stuff like that. So you're going to have a magnetic moment in the coil. It's going to tend to align with a fixed magnet in an analog meter. Now, most meters that use are digital, not analog, and even analog meters do things electronically as opposed to necessarily having an actual coil deflecting in a magnetic field. Your best meters do the coil in the magnetic field, but electronic meters are pretty good too. Okay. Okay, well, the coil is very sensitive. It doesn't take much current at all, just a little tiny bit of current, just a fraction of a microammeter will twist that coil all out of shape. So you don't want to have much current going through the coil. Now, if you want to measure voltage, you do that one way. If you want to measure current, you do it another. Okay? If you want to measure voltage, well, your voltmeter consists of what I've circled here in orange. Consists of a high resistance in series with a coil. Okay? It's a high resistance, so when you put it in parallel over, let's say, the resistance in your circuit, it doesn't affect the current in the circuit very much. Because you have a high resistance, very little of your current will go through this resistor. Presumably this resistor is much higher, this resistance is much higher than this one. And this resistor then draws very little of the current. Now, you always have to kind of be aware of what the resistance of your meter is and make sure it is a whole lot bigger than the resistance across which you're measuring the voltage. But in the case where it is, that's how it works. So you got a high resistance, and that also protects the coil. You got to have a high resistance with the coil. If you don't have a high resistance protecting the coil, you would have a significant current that goes through here. You'd destroy the coil. Or you'd blow the fuse if you're using an electronic meter. If it's a digital meter, well, it kind of adjusts itself. And we're not going to go into the electronics of how that works. Okay. So this is how you measure voltage, and you measure it in parallel. Now, if you put this voltmeter in series, what would that do? Well, a voltmeter in series puts a great big resistance into your circuit. Here, that resistance is parallel to your circuit. It doesn't interfere much. It doesn't interfere with the current going around the circuit. The only interference is it draws a little bit of the current, so it actually reduces the current in the circuit a little bit. If your resistance here is high enough compared to this one, we regard that as an insignificant effect on the circuit you're measuring. Okay, so, but if you put it in series, the voltmeter just kills your circuit. Now the voltmeter has a huge resistance protecting the coil, so you're not going to hurt the coil. Now, if you measure current instead of voltage, you want this arrangement. Now, this arrangement, again, you have a high resistance protecting the coil, and you have a low resistance here. So that whatever current is flowing, when it gets to this point, it'll branch off. Part of it will go through the low resistance, part of it will go through the high resistance and the coil. Since you don't want much current in the coil, that's just exactly what you hope for. So, most of the current is going to go through this low resistance, and since it's a low resistance, hopefully this resistance is quite a bit higher than the low resistance, and that's all that's really required in order not to interfere with the circuit, because if this resistance is 100 times as great as this resistance, then this resistance doesn't add much to this, okay? Going through this resistor doesn't dissipate much energy, doesn't reduce the potential by very much. And very little current is going to go through the coil. Almost all it's going to go through here. So the current that goes through here will be almost equal to the current that would have gone through the circuit if the meter wasn't there. So here's your meter. Here's your ammeter. So let's put a big old A on this thing. Let's put a big old V on this thing. This measures voltage. This measures amperage. Now, the problem with an ammeter is you can damage it. Because if you put an ammeter in parallel, like this is the way you would hook up a voltmeter. If you hook up an ammeter the way you would hook up a voltmeter, what's going to happen? The current's going to come to here, and it's going to have the opportunity to go through this low resistance right here. It's not going to go through the big high resistance, but it's going to go through this low resistance in preference to going through this resistance, which presumably is a lot higher than this resistance. Well, this resistor isn't designed to take a huge current. Okay, but if you expose this resistor directly to the voltage, which is essentially what you do here, okay, you have this voltage across this resistance, you're going to get a very high current and you're going to burn up this resistor. Or you're going to blow the fuse, because you probably have a fuse that prevents that from happening. But if you blow up the fuse, then I'm going to have to go find the fuses, take your meter apart, and fix it. Okay? Now, I really don't mind taking the meter apart and fixing it, but you know how things are in this lab. Am I ever going to find those fuses? No, you're going to be without a meter. Well, actually, I kind of know where the fuses are, but don't count on it. Okay, so anyhow, there you have what you need. And your book tells you the same thing. This is what you need to know when you're using meters. And the bottom line is, the one thing you don't do is you don't hook the ammeter in parallel. That damages the meter. That causes me to have to go find fuses. Okay? Now, if you hook a voltmeter in series, that's not good either, but it doesn't do any harm, really. You just don't get anything. You don't get any result, except you pretty much measure the voltage of the source. But you don't get any current, or very little current, because this is such a high resistance.